back to our YouTube channel. Today we are back in class and we want to look at Waec practical for year 2026. From the experiment given to us, we are looking at this apparatus for mechanisms. These apparatus they give us for mechanisms, and for this apparatus I try to deduce this setup, and from this setup we can deduce out two tables for table 1 and for table 2. Let's go and dive into the experiment fully. Now this is the experiment stand. Now we have two return stand. This is the first return stand, this is second return stand, and on my first return stand I put my spiral spring. I clamp my spiral spring with my optical pin as my pointer, and on the second return stand I clamp my meter rule. So what I want to do is that for this first experiment that I'm doing, I'll first try to put my pointer close to my return stand, and I will record my initial length of my spiral spring, and that will be my head knot. And the subsequent experiment that I will do is I will loading my masses on my mass hanger, and I will put it on my spiral spring to get the increase in length, which will give me my extension. So the first thing is, let's look at the initial length of our spiral spring. Now if you look at it very well, my initial length is of this spiral spring is 42, and that is my initial length. That is head knot. I will record it. That is 42 centimeter. So the next thing is, from my table of value and from what has given to us, they said we should use 150 mass. The first is 150 mass. I'm trying to load my mass to my mass hanger 150. So I'll put this mass on my spiral spring and look at the increase in length that will happen to it. Then I will record my increase in length. So this 150. So I want to look at, if you look at it that way, that is 37.5. 37.5. For my 150, I have 37.50. Then I'm going to add another mass 50 to make it 200, and check my increase in length that will happen to it. So this is 35.8 for 200. Right now we are coming to 250. Let me slot in another mass and get our increase in length for 250. So if you look at that way, we have 34.1. Like for 250 we have 34.1. Then I slot in another mass for my 300. Mass 300. I want to get my increase in length that will happen to it. So that this is 32.4. 32.4. And for my last mass, which is another 50, that will make it 350. Let me get my increase in length that will happen. So if you look at that one this way, well, we have 30.8. 30.8. So this is my table of value. So the next thing is to use my calculator to minus my increased length from my initial length to get my extension, which is E. That is 42 minus 37.5. So we have 42 minus 37.5. We have 4.5. 4.50 42 minus 35.8, 6.20. 42 minus 34.1, 7.90. Then we have 42 minus 32.4, 9.60. Then we have 42 minus 30.80, 11.20. Table for our table 1. So the next thing they may ask us to do is to plot our m against e. So this is the likely question we can get out from our setup, and this is the table 1 that we can deduce from the experiment. Now let's move to table 2 and use the setup also to get out the likely values that we can also formulate out for table 2. Now coming back to table 2, still using this same setup, the difference between this table 1 and table 2 is that in table 2 they may ask you to oscillate your masses vertically and use your stopwatch to count the time that oscillation is going to take based on 20 oscillation, the time it will take. And after you have gotten your time, you now get your period, which is capital T, which is your time over the number of oscillation, which is 20. Then here we get our T squared. Now let's get to our experiment and do the experiment for this table. Now this is set up for our table 2. So what we want to do now is to oscillate our masses. I want to start from 350. This 350 mass, we want to start from 350 till we get back to 150. So this is still the same setup like that of table 1, but the continuation for this table 2 is if they ask you to oscillate your masses vertically and get the time taken. So let's oscillate vertically now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. At 20 oscillation, our time is 1450, 13.71. Now, so let's remove 1, which is 50. So this for 300, we'll do our oscillation and get our time taken for 20 oscillation again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We got 12.68. Let's go for 1. This for 250. Vertical oscillation again, and we get our time taken. So let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 11.71. Let's go for 200. Let's go for 200. Let's go for 200. And that vertical displacement, a vertical oscillation, and get our timing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's do for the last one, 50 gram. For 150 gram, let's do our vertical oscillation again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.19. So this, we have gotten our time taken. The next thing is to get our t. So we want to get our period time t, which is t divided by n, and our n is 20 oxidation. So this 9.19 divided by 20, we got 0.4595. Then this one, 10.45 divided by 20, got 0.5225. Then another one, 11.71 divided by 20, got 0.5855. Then 12.68 divided by 20, 0.6340. And 13.71 divided by 20, got 0.6855. So what to do now is for us to get to be able to put this value on our graph very well. For you to make it easy for you, you can multiply this table by 1000. So on our table, you can write times 10 raised to the power 3 here, that you are multiplying by 1000 to be able to get a whole number or a value that will be easy for you to locate on your graph. So let's multiply this one by 1000. So we got 6. Okay, let's multiply by 100. I think 100 is more easier for us for this one. So we multiply by 100, we are going to get 68.55 for this last value. And for this second to last value, 0.6340 times 100, it will give us 63.40. Then this one will give us times 158.55. So after we have multiplied our total value by 1000 by 100, we got 58.55, and after we have multiplied this one by 100 also, we get 52.25. So let's multiply this one also by 100 also, we are going to get 45.95. So this times 10 is power 2. Now for t square, let's use this value that we get when we did our t. Do you understand? When we did our t, let's use this value, so that if we square it, we'll be able to get a value that will be more easier for us. That will be 0.4595 square. 0.4595 square. That is 0.2111. Then for this one, 0.5225 square, we got 0.2730. For the next one, we have 0.5855 square, 0.3428. Then 0.6340 square, 0.4019. Then for this one, we get 0.6855 square, 0.4699. Now to record our value here, we can pick it to two decimal place, 0.21. Then this place we get 0.27. Here we get 0.34. This one you get 0.40 to two decimal places, and here we get 0.46. This one you pick this value is we write this value on this our table is for us to be able to locate this value easily on our graph. But make sure that any table that you are filling, you must make sure that you are maintaining a kind of consistency. You see that for all this our table, we maintain what? To two decimal places. Do you get me? So in our table of value, your you have to make sure that there is consistency in your what, in your table of value that you are recording in your table. If for a column you are using 2 decimal places, you have to use 2 decimal places all through. If you are using 3 decimal places, you must use 3 decimal places all through. So there must be consistency in what, in your table that what you are plotting. All right, so now this the value for our table 2. Now this table, they may ask us to plot our m against t square, or we should plot our e against t square. That is the what, the graph they may ask you to plot from this table. Now let's go to the theory aspect of this question that they may ask from you. The theory aspect of this practical. Note that this experiment that we finish is talking about Hooke's law. So you have to know everything that has to talk about Hooke's law, know about Young modulus, how to calculate Young modulus. You have to know about stress, you have to know about strain. Then you have to know about calculation that has to do with Hooke's law, which is the calculation that we are going to do with in this question. So I want to leave you with this question that in number 1 and number 2. I want to see the answer in my comment box. Tell me, state Hooke's law for me and state what elasticity is for me. So but let's do this calculation aspect together. Now for this aspect solution, here we want to calculate the energy stored in this spiral spring, and our formula can be E is equal to half ke squared. Now, knowing that your Hooke's law, I don't want to divide it, but I will give the mathematical expression because I want to give you that in our comment box. Know that our M is equal to Ke. Now, making our K the summary of formula here, we have K is equal to F over E. And knowing that in this formula for energy that I wrote here, I say half is equal to Ke squared. So if I substitute my K is equal to F by E into this formula, then we are going to have E is equal to half. I substitute F, our K is equal to F by E into this formula. We have F over E times E squared. So if I cancel this square and this E, which you don't use to cancel it in mathematical expression, but let me cancel it here. So what I'll be left with is now what? Is now the half F times E, which is half Fe. So for this formula for our, we can have this formula for energy to be half Ke squared, or the second one that we derive, our E is equal to half Fe. But in this question, let's look at the formula that we can use. Here they give us the extension E is 0.3, and they give us the first constant, which is K. Our K is 300 Newton per meter. So here, this formula that we are going to use because we have the parameter for heat. So let's use this formula to solve this question. So let's substitute our value in this formula. We have E is equal to half times our K 300 times 0.3 squared. So that's we have our E is equal to half times 300 times 0.9. 2 divided by this one, we have 150. 150 times 0.9. If you do your calculation with your calculator, you're going to get 135 joule. So that is calculation. This is how to solve this question. Also, we make sure that our pointer is what was rightly positioned. Then the last precaution that we did here is what? We make sure that there is consistency in our value. When we are getting our value that we recorded on our table. Maintain consistency. In the table of value. Alright, so these are the 4 precautions that we observe during our experiments. In exam, they may they ask you to only give 2 or maximum 3 precautions taken during the experiment that you did concerning this aspect of Hooke's law that we did. So you should be able to write some of these precautions in your examination that you may ask from you. Alright, this has bring us to the end of this concept. I believe that you are able to gain enough from this practical experiment that I did concerning your Waec question that might be given to you in your examination hall. Please do not forget to like this video. Do not forget to comment on some critical aspect that I explained in this video, and do not forget to share with your friend for other students to benefit from this video. And lastly, do not forget to subscribe to be able to have access to some other video that we are going to do on this concept. And watch out for a video on light aspects of this practical for your white practical, and also watch out for video on electricity. We are still going to drop those 2 videos on our YouTube channel, so do not forget to subscribe to have access to those videos.